Hi, this is Wagner Kamakura, and I'm going to show you how you can use my analytic tools to run a multiple correspondence analysis. This will allow you to map rows and columns of a table into a reduced space so that each row and each column will be a point in this joint map. I hope by now you have already gone through the tutorial on principal component analysis because correspondence analysis is very similar in principle and in purpose to principal component analysis. Both are dimension reduction tools. Principal components defines a reduced space to account for most of the variance in the original continuous variables. Correspondence analysis attempts to do more or less the same, but to account for most of the chi-square in the original table of rows and categorical columns. So the main difference is that PCA is applied to continuous variables, while correspondence analysis is applied to categorical variables. Multiple correspondence analysis, as I said before, produces a map where each row and column is represented as a point in a joint map in a way that the inertia in the map best reflects the chi-square in the original table. And what do I mean by inertia? Inertia is nothing more than the sum of the distances between every column associated with a row, or the reverse, the sum of the distance between all the rows associated with a particular column. And this is done by producing a map where each row is at the centroid of the columns it is associated with, and each column is at the centroid of the rows that it's associated with. Interpreting an MCA map is fairly similar to principal component analysis. Rows that are placed close in the map have similar column profiles, and columns that are placed close to each other in the map are associated with similar sets of rows. This will become clear with an example. Now, the one thing you have to remember is that the proximity between rows and columns in the map is not directly interpretable because the proximity is relative to the barycenter of all points associated with the focal row or column. And you may want to Google this. This is called the barycentric principle in correspondence analysis. We're going to try to see the intuition behind correspondence analysis with this example. What I have here is a knowledge audit that I did with 46 MBA students prior to taking a data analysis course. Essentially, I had a list of Excel tools and functions, and they reported their knowledge about each one of those tools and functions. 1 means I used it before or I know how to use it. 0 means don't know, and I have a collection of tools and functions. This is a subset of the data. So here's the data. As I said before, I have 46 students in the rows and 24 tools and functions from Excel. What we want in this correspondence analysis is to produce a joint map of rows and columns, students and topics, so that a student will be at the center of the tools and functions that he or she knows. And each one of those tools and functions are going to be at the center of students who already know them. I go to Add-ins, Kamakura's Analytic Tools, Correspondence Analysis, and you can analyze a maximum of 5,000 rows and 150 columns. You need to highlight the data. And we're going to ask for a two-dimensional map. And here we have each one of the students from 1 to 46 are mapped in the same space as each one of the 24 topics. So two students who are close to each other, for instance, 9 and 45, they have similar knowledge profiles. So these two students seem to be more familiar with the number crunching functions of Excel. VLOOKUP, count blank, index, if, but not as much with the charting features of Excel, such as radar charts, surface charts, bar maps. And you can see that the maps and charts tend to be in more or less the same area here at the bottom of the chart, while the top of the chart is more associated with data analysis or data management. So again, the goal of correspondence analysis is to place, in this case, students or roles at the center of the column or tools and functions that they are familiar with, at the same time that it places columns, tools and functions at the center of the roles or students that are familiar with them. And here are the results. Very similar to principal component analysis, we have here the percentage of chi-square explained by each one of the dimensions. So the two dimensions here in our map explain 36% of the total chi-square in the original table. We probably could have used one more dimension to explain 11% more.